Neural networks, deep learning. You hear these terms everywhere now, right? They're powering everything from your phone's camera to these huge scientific breakthroughs. It really feels like it all happened overnight. But the real story of how we got here? Wow. It's this incredible roller coaster of genius ideas, absolutely crushing disappointments, and then this final spectacular comeback. To really get what's happening now, we have to go back and ride that roller coaster.
So that's the big question, isn't it? Why now? Why are these networks suddenly crushing it in competitions like ImageNet and solving problems that, just a decade ago, we thought were basically impossible? Well, to understand the boom we're living in, we gotta go all the way back to the beginning of the dream.
The whole idea, right at its heart, was just wildly ambitious. The goal was to build an artificial brain. Seriously, researchers wanted to create a machine that could learn from experience, the same way we do.
Okay, so take a look at this because it's pretty cool. On the left, you've got a real biological neuron from your brain, and on the right, the artificial version. The basic idea is pretty much the same. It takes in some information, thinks about it, and spits out an answer. But the real magic is in the connections, the synapses. In our brains, those connections get stronger or weaker as we learn things. In the artificial version, those are just numbers. They're called weights. And the whole game is about adjusting those little numbers, turning them up or down until the network gets really, really smart.
So, this grand vision of an artificial brain, it had to start somewhere. And that start was the very first attempt to build one of these artificial neurons. A machine that would kick off decades of hope and, yeah, a whole lot of frustration.
So here we are, 1958. A machine called the perceptron is created. And this wasn't just some idea on a blackboard. It was a real physical thing. And the hype was enormous. I mean, people really thought, this is it. The age of thinking machines has finally arrived.
And just look at this thing. This gives you an idea of how big a deal it was. The Mark-I perceptron was a massive piece of hardware. It took up a whole room. This wasn't a little program you run on a computer. It was a serious engineering project, the physical embodiment of that artificial brain dream.
You can just feel the complexity looking at this control panel, right? This incredible web of wires and dials, all of it just to make a single artificial neuron learn. It was completely revolutionary for its time. But, and you knew there was a but coming, there was a catch.
Yep. For all the impressive hardware and all the massive hype, the perceptron had a really big flaw. It turned out it just couldn't solve certain problems that honestly seemed pretty simple. And just like that, all that initial excitement started to fizzle out.
And that failure, it kicked off what's now known as the AI winter, a long, cold period for this kind of research. The dream wasn't dead, not really, but it was about to go into a very, very deep hibernation.
So what was the killer flaw? It's right here. The perceptron could only solve problems if the answer could be found by drawing a single straight line. Think about it like this. If you have a piece of paper with red dots and blue dots, and you can separate all the red from all the blue with just one line, the perceptron could do it, no problem. But if you couldn't, it was totally, hopelessly stuck.
And this limitation wasn't just a hunch, it was mathematically proven in a famous or infamous book in 1969 called, you guessed it, Perceptrons. The book was so convincing and so pessimistic that it basically put the nail in the coffin. Funding dried up, researchers left the field, work on neural nets just slammed to a halt. And if you want to know what the mood was like back then, just listen to this quote from a researcher named Paul Werbos. This is the truly tragic part of the story. In 1974, he actually figured out the solution to the perceptron's big problem, a method we now call backpropagation. He took his world-changing discovery to the top minds in the field, and nobody cared. The door had been slammed shut, and no one was interested in opening it.
But you can't keep a good idea down forever, can you? Decades later, that long AI winter finally, slowly started to thaw. And it was all thanks to the rediscovery of that exact same idea that everyone had ignored.
So let's look at this timeline again. It's kind of crazy. 1974, Werbos has the key and nobody listens. Then, a whole 12 years later, 1986, a totally different group of researchers, Rumelhart, Hinton, and Williams, they figure out the exact same thing all over again. And this time, the idea stuck, and the field slowly started to come back to life.
So what is this magic thing, backpropagation? Well, in simple terms, it's a really clever way for a network with many layers to learn from its mistakes.
It figures out how wrong its guess was, and then it sends that error message backwards through the network, telling each and every connection exactly how to adjust itself to do a better job next time. This was the breakthrough that finally unlocked deep, multi-layered networks.
But here's the next twist. Okay, so problem solved, right? They had the secret sauce. Well, not quite. There was a little burst of excitement in the late 80s and 90s, but for the most part, the winter just kind of continued. Get this. By the year 2000, researchers had already come up with most of the network designs we use today. The only problem? They didn't really work very well. The dream was still just out of reach.
And that finally brings us to today, the revolution. Suddenly, all those old ideas are working, and they're working unbelievably well. Which brings us right back to our very first question. What finally changed?
Let's just put it out there directly. If the blueprints for these incredibly powerful networks have been sitting on a shelf for over 20 years, why is the explosion happening now? What were the missing pieces of the puzzle?
And here it is. This is the answer. It wasn't one new brilliant idea. It was two other things that finally showed up to the party. First, data. The internet gave us absolutely massive, unbelievable amounts of data to train on. And second, power. We developed the sheer computing horsepower, thanks to things like gaming GPUs, to actually process all that data. This chart says it all, really. Look at traditional machine learning. You give it more data, and its performance gets better, but then it levels off. It hits a ceiling. But now look at deep learning. These networks are data hungry. The more you feed them, the smarter they get. They just keep going up and up. They were perfectly built for the big data era.
And that's the whole story right there. The revolution didn't come from a single new invention. It happened when these old, brilliant ideas finally met the new resources they needed to thrive. The data and the power finally caught up with a dream that was decades old. Which brings us to one final, pretty mind-blowing thought. We are getting very, very close to the point where we'll have the power to train networks that have as many connections as a human brain. So what happens then? Well, that's a pretty good question. Your guess is as good as mine.